I'm going to do problem 19.2, which is pretty representative of how you use this formula to model something in real life, what's actually going around. So this is the basic formula again for chapter 19 that you should just know. It's basically a sine wave that's shifted and dilated and compressed in all the different ways that you can. And then we got to try to match it to our physical situation. So the first thing you always do is draw a picture. And so they kind of hold your hand here. And in part A, they say sketch what the situation looks like. So it says that at time t equals 0, which is nice actually, they start at 0. Sometimes they don't, and then you just started at 2 or whatever, but it's always easy to start at 0, and they do. At time t equals 0, it's pulled down to point, so you have a mass on a spring, so pulling the mass down to point 10 centimeters above the ground and released. After that, it bounces up and down between its minimum height of 10 and a max height of 26. And its height is a sinusoidal function of time. Okay, so goes from 10 to 26, so we don't need anything below 10. So we're going to draw our axis here. Okay, we don't need anything in the negative, and I'm going to put my 10 down here in the bottom, and it's okay if this gap here doesn't make sense, right? Because who cares? We're not going to go down there, and it's kind of nice to put it near the time, so I don't want it to be way up here and do it to scale. And it's nice to have where the 0 is, so whatever. Okay, then up here, somewhere at the top here is 26. So it's going to start us off here at 10. And then it says it gets to 26, its max height in 0.6 seconds after starting. So it gets up here to 26.6 seconds later. So we want to make that, somewhere over here maybe. We don't want to squish it too much. So I'm going to make 1 second, like right about here. So here's 1 second. Then 0.6, here's 0.5. So maybe this is 0.6. So 0.6, it's about right there. Okay, there's 0.6 seconds. Okay, then let's see, if it gets to the maximum height at 0.6, then it's going to come back down to the minimum heights 0.6 seconds later, so that's at 1.2. So right about here is 1.2, it's going to be back down here. Okay, so clearly the period is from where it is one place, from a similar point to a similar point. So it's 1.2 seconds. We know in 1.8 seconds, let's see if that's 1, there's 2. At 1.8, it's going to be back up here again. And then at 2.4, so let's see, here's 3, 2.4, here's, so 2.4 is like right here, it's going to be in the bottom again. And it's just going to keep going up and down. So now we can draw our sine wave. Starts going up, peaks, kind of tricky to draw these things, right? Comes down, oh, this is a bad sine wave, goes down, comes up, that's a better one. Comes down, comes up, and keeps going on and on and on. Okay, now this is a little bit lopsided sine wave, which actually is not good, because it's easier to think about things if they're right. So I'm going to try to do mine a little bit better here. Goes up, so it kind of comes down like this. It's just a little bit better. I'll make my dot there bigger, that kind of smears it out, makes it look better. Okay, that's what's going on. Now, between 10 and 26, the average right there, you just take 10 plus 26 divided by 2. That's 36 divided by 2, which is 18. So the middle is 18. We know that. From peak to peak here is 1, or valley to valley is 1.2, or peak to peak is 1.2. Okay, and from between the peak and the valley, between the valley and the peak, if that's 0.6, we know that it's in the middle at 0.3. Halfway there is 0.3. So right there is going to be 0.3, halfway between 0.6, right? The bottom at 0, top at 0.6, it's going to be the middle at 0.3 seconds. So now we know everything we need to know here. It's kind of cool. So let's see, the amplitude is from the middle to the top, or the middle to the bottom. So that's 26 minus 18, which is 8. So A is equal to 8. So this is part B now. Part A just wanted to draw it. So A is equal to 8. B, the period, is from 0 to 1.2, a full cycle. So B is 1.2. And C is where the wave starts. And our wave is starting right here. Sine waves always start from the middle and on the way up. Not from the middle down, from the middle to go up. Our wave starts at 0.3, so a normal sine wave starts right here, right? Starts at 0 and starts going up. Ours is starting here, so our C is 0.3, again, that's kind of the tricky one. It's from the middle, from the average height to where it starts going up. And then the average is 18. So D is equal to 18. Okay, so we know all those numbers now. Now we know everything we need to know about our wave. Part C, though, says give 4 different possible values for the phase shifts. That means C. It's kind of nice that part C is C. So what are 4 different values of C? Okay, so I said C is from the middle to where it starts going up. But here is the middle over here to where it starts going up. And over here is the middle to where it starts going up. And if I continue this, you know, we have another one over here. And I could go negative and have them over here somewhere. It's making my picture messy. The middle to where it starts going up. There's an infinite number of things you can have for C. And they're all right. But typically you have the first one, the easy one. But the way you'd write that then is, okay, C can be 0.3. That's one we got. Plus, the next one is at 1.2 seconds, a full period later. Right, the period's 1.2 seconds from the same place to same place. And then another 1.2 seconds and another 1.2 seconds. So the easy way to write that is 1.2 times n, which are multiples of 1.2, because you don't need to write this. I'm going to write it now to remind you, but n is, you know, -2, -1, 0, 2, 1 comes after 0. 1, 2, ... That stands for integers, right? That's why I like n. The book sometimes uses k. They like to use k for the integers. I like using n because integers, right? Integers, makes sense. So that's what n is. It can be negative, it can be 0. We normally take the 0 one. That's what I like to write in here because it's the smallest one, it's the simplest one. But, you know, sometimes it might make sense to use a bigger one. Okay, infinite number of those. They said to write down 4. We did better than that. We wrote down an infinite number. Okay, D, all they want you to do now is write down the formula. So we just plug in all our numbers into here. Okay, so Y is equal to A, which is 8, times the sine of 2 pi over 1.2, right? B is 1.2, so you plug that in. T minus C, C is 0.3. And then plus the average value, which is 18. Okay, so that's it right now. We can plug in anytime we want. Make sure your calculator's in radians. Calculator has to be in radians for this to work. And then we can figure out the height at any time that we want. Notice we could simplify this, like a 1.2 in the bottom is, you know, not very mathematically cool or acceptable usually. Except here, it is acceptable because now instantly I can look at this formula and go, oh, the period's 1.2. If I made this some kind of pretty thing, like what, multiply the top and the bottom by 5, that'd give me a 6 in the bottom, that'd give me a 10, so I could do 10 pi over 6, or what's that, 5 pi over 3. Yeah, maybe mathematically it's a better way to write it, but then I'd have no idea what the period was. I'd have to figure it out. Why'd you figure it out? Just leave the period here, leave it 2 pi over the period. Then right away I know, oh, this thing cycles back and forth every 1.2 seconds. Much better. All right, part E says, what is the height after 0.18 seconds? So all they're saying is, okay, let's see if you can use a calculator. Plug in 0.18. So plug in T equals 0.18. Make sure your calculator's in radians, and you can figure out what the height is. I'll let you figure that out. We could guess in 0.18 seconds, that's somewhere going to be over here, right? 0.3 seconds, here's 0, so it's not going to be very high. So when you do this, what, maybe 11 or something? Here it's 18, 11, 12, 0.18, it's a little bit halfway to 0.3, so yeah, maybe 12 or 13. Okay, you can figure out. Unfortunately, the back of the book does not have all the answers. It just has this formula, which is unfortunate. But you could plug that in and convince yourself it's right. And you can plug this into Desmos. That's what I would suggest you do, actually. Plug this into Desmos, and then you can totally just look at the graph and figure it out. And then leave it on Desmos, and then you can just change the numbers real easily for all the other ones. And it's really, really helps. But draw the graph too. It really, really helps to draw it yourself. Okay, then finally, F is the trickiest one. During the first 10 seconds, how many times will the weight be exactly 22 centimeters above the floor? Okay, so the first 10 seconds, when will Y equal 22 centimeters? How many times? This is where having the picture really helps. So let's go back up here. here's 18, here's 26, so 22 is halfway in between, right? Because 22 plus 4, 22 minus 4, yep, that's right. So it's going to be here and here. That's less than 1.2, and then it'll do that here again and here again. It'll be at 22, and then we're up to about, somewhere around 2 seconds, and then up to here it'll do it again, and we're around 3 seconds, and up to here, and I'm going to quickly run out of my picture because my picture only goes to like 3 here, and I could do maybe a 4, but I'm not going to get to 10, so we're going to have to be clever about this. I don't want to draw my picture all the way out. Now, if you use Desmos, you could figure this out, but the point is to use this, figure it out without Desmos, and then check your answer on Desmos. Okay, so what we figured out, though, is every 1.2 seconds, every cycle, we're going to have 2 of them, on the way up and on the way down. So how many 1.2s fit into 10? So we just go 10 divided by 1.2, and that is 10 divided by 1.2 is 8.33. So we have 8 full cycles in there, and then a third of a cycle left. Okay, so we have 8 full ones and then a third. So we know we have 8 full, so 8 times 1.2 is 9.6. So we're going to have that extra 0.4 seconds. That's the tricky part. Will we have one in that extra 0.4 seconds? I hit exit the 1, that's no good. Times 1.2. Okay, every one of those has 2. Every 1.2 seconds from here to here has 1 here, right on the way up, way down. So we know we're going to have 8 times 2, which is 16. We know we're going to have at least 16. The question is, in that last 0.4 seconds, are we going to get up to 22 or not? And if we look at that, so it's like we're right here, we're right at the bottom of the cycle, or we could pretend we're right here, whatever, it doesn't matter. We're at the bottom of the cycle, let's do it way over here. Let's pretend right here is 9.6, even though it's not, but I don't want to draw off my paper. So the bottom is 9.6, 8 full cycles from 0. Here's 0, 1.2, 2.4, all the way to 8, which is 9.6. So the question is, in 0.4 seconds, will this last one here, so when we get to 10, will that last 22, will it be before we get to 10 or after we get to 10 seconds? That's the trick, and it's going to be close. Because like if we look over here, 0.3 seconds is halfway. So we know at 9.3 seconds, at 9.9 seconds it's halfway. That's 9.9. And halfway is 18. So in that 0.1 seconds, is it going to get up to 22? We have 0.1 seconds to get to 22 because it takes 0.3 to rise to the middle, which is 18. Yeah, that's going to be close, right? So how do we figure that out? And really the only way to figure it out is to plug it in here and see where is this thing at 10 seconds. At 10 seconds, if y is above 22, we know it's not going to be past that point, right? It's really close. There's no way this point comes in. It's only if we get one more point in. So the question is the answer going to be 16 or 17? So we're going to have to plug 10 seconds into here and into here for t and see if we get if it's going to be bigger than 22 or less than 22. So I'm going to try that. So we have y is equal to 8 times the sine of 2 pi over 1.2 times 10. We want to, where does it 10 seconds? 10 minus 0.3 plus 18. Calculator in radians mode. Okay, so now I'm going to do a lot of calculator work here. So that's 0.7. So it would be 2 times pi 2 times pi times, what am I saying? 9.7, 10 minus 0.3 is 9.7. So 2 times pi times 9.7 divided by 1.2. Okay, I get 50.7. Make sure my calculator's in radians mode. Take the sine of that. So sine of that. And then multiply by 8. And add 18. And it's exactly 22. So at 10 seconds, it's exactly 22. So I think that counts, right? It says how many times in 10 seconds to get to 22. It is exactly 22 in 10 seconds. So we'll say 17. Unfortunately, they don't give the answers in the back of the book, but you could check this on Desmos. So 8 full cycles of 2, and then we get one more at 10 seconds. All right. You should not have to use the next chapter is where we figure out inverse sign. Like, okay, what time is y 5? And then we have to go inverse sign. That's the next chapter. We're not going to deal with that now. So that's another way to figure these out, but you don't need to know that. You can just kind of do it this way with a really good picture. Okay, hopefully that helps. Almost all these problems, should I say all of them? There's always some weird ones, but are kind of examples of drawing the good graph and figuring out all these things really carefully think about where the things are, and again checking it on Desmos to see if it makes sense. And like I said, they don't have all the answers for all like A, B, C, D's, but they have the main answers in the back, so you can check your work. And I can give you more answers too for some of them. Like number 1, I just noticed only had A and B, and I did A. So I should probably get those answers too, so you know that you're doing it right. So, okay, hope that helps. Bye.